So I'd like to introduce our moderator for the panel, Joe Powell. Joe is the Chief Scientist at Shell and has been a great friend to the center, very helpful on the work we've been doing in the hydrogen space, and just is really such a wealth of knowledge about energy innovation and clean tech, and has been working with a number of colleagues at the universities. And so I thought he would be the perfect person really to start this this next discussion. So Joe, I'm going to put a slide up here with your panel here and turn it over to you.
All righty, Brett. Well, again, this is Joe Powell, Chief Scientist, Chemical Engineering for Shell. And I'd like to start by thanking you, Brett, and your colleagues at the center for organizing this exceptional event, and the focus today on Houston's role in low carbon energy innovation. So energy remains front page news. And today, a very large portion of the public and our global stakeholders in energy are becoming increasingly adamant and very passionate about moving now to a clean energy future. So delivering clean energy will require an unprecedented transformation in our energy systems, technologies, and infrastructure. This is what keeps us up at night. And how are we going to do this? So innovation hubs are most often associated with the West Coast, East Coast, London, and now Beijing. But Houston is known as the energy capital of the world. So how can we leverage that expertise and create an ecosystem that delivers on this massive transformation to clean energy? Our panel here today will address that critical first step in generating ideas and transmitting them from basic to applied research. And so what I'm going to do next is to introduce our panel members, who are going to start with an overview of their particular institute or university's incubator system, and also its unique capabilities in low carbon energy. So to this end, I'm honored to introduce Dr. John Attia, who is Texas Instruments Endowed Professor and Interim Director of the Smart Grid Center at Prairie View A&M University. John, welcome. I will now give you the floor to present a brief overview of Prairie View's role in the energy innovation ecosystem.
Want to bring the slides up? Okay. So at Prairie View, we have several projects that are going on in the area of low carbon energy. The first project is on efficient system for carbon dioxide capture, hydrogen production, and electricity generation. This project uses electrochemical process that can continuously produce electrical energy and hydrogen through efficient carbon dioxide capture. And we envisage that it will have applications in automotive and also in core industries. The second project, titled Carbon Dioxide Capture Using Amino Acid Solutions and Guanidide Compounds. This project is being sponsored by Oak Creek National Lab. And one of the main sources of carbon dioxide emission is in combustion of coal, is that when the carbon dioxide is formed, it's formed in the waste flue gas stream. The preferred post-combustion process for separation of the carbon dioxide from the flue gas stream is chemical absorption by amine solvents. However, high energy is required to strip the carbon dioxide, and this project is basically ongoing. We have shown some results, and we think that this will have a lot of applications in future. The third project, which I'd like to discuss, is a renewable energy bike lanes, and this project is being funded by the National Science Foundation. The goal is to develop composite power generating cells that will generate power under pressure. We intend to fabricate an integrated part system of power generating cells, charge collection circuits, battery storage, and plant and paint. We'll install and test a system at Kuala Lumpur, Malaysia. And we think a similar project can be done in the city of Houston. The other, since I don't have enough time, I just listed additional projects that are ongoing at Prairie University. The modeling and simulation of low-cost, high-efficient solar cells, the carbon capture using a nano-absorbent, capacity mixing in porous electrodes for energy production. And then we have several of our colleagues at Prairie View who are doing some work on offshore wind energy. So that's my introduction.
All right, John. And I'd like to now turn the presentation over to Dr. Ramanan Krishnamoorti, Professor of Chemical and Biomolecular Engineering, Petroleum Engineering and Chemistry, and also Chief Energy Officer at the University of Houston. So Ramanan, please share your introductory perspectives.
Thank you so much, Joe. Real pleasure being here. Brett, thank you for organizing this and putting this together along with Laura. Appreciate the opportunity to be a part of this wonderful panel with my colleagues, John, Stratos, Varun, and Ken. It's a real honor to share the stage with each of you. I want to tell you briefly about what we do at the University of Houston. You've already seen some of the work output from our study with the Center for Houston's Future on how Houston can become the low carbon energy capital of the world. But part of this is we can carry out those kinds of studies, but really the way we make a difference is if we can translate some of these things into commercial developments. And this is where I'm going to try and focus my conversation of the kinds of things that we are doing. And I'll talk about it in pretty general terms, and happy to sort of jump into specific conversation as and when ready. We have a world famous entrepreneurship program in our Wolf Center for Entrepreneurship, one of the highest rated undergraduate programs for entrepreneurship. And our students there are certainly very much focused on energy and clean forms of energy as they move forward. A couple technologies that have been advanced through there. One has been something called Sensitech, which is a sensing cementing technology. And the other one is Recycle, which is rare earth recycling. And these have sort of advanced to the point where they're being commercialized and being developed from inventions that came out of the University of Houston. We take that type of entrepreneurial activity in our students, run them through experiential learning. And this is where our partnership with industry here in Houston has been invaluable to really get our students that experiential learning. And then we try and accelerate that learning. And for accelerating that learning, we have developed an incubator at our technology bridge, which is about half a mile away from our campus here. It's connected by shuttle buses and the like. It was the old Schlumberger facility, is about 75 acres of space. And we've created an incubator there, an office incubator along with a lab incubator, 30,000 square feet of lab space that allows people to come in there with wet lab technologies and to come in and accelerate that progress. Along those lines, sort of the four big tenets of innovation that we've tried to focus on have been talent, density, try and create that density. That's what that tech bridge has done. And then create a network. Towards creating the network, we've created a website, and I'm going to share that in the chat box as soon as I get a chance to do it, which will give you a map of the technology innovation that's happening all over the city of Houston. And this is something that we are extremely proud of. It captures all of the technology innovations that are happening within the city and beyond, and really gives you a single place to look at these networks. And the last one is really capital. This is the part where we're trying to capture the attention of venture capitalists as well as angel investors in trying to advance some of this work. Two places where we've identified capital opportunities. One is through our Center for Carbon Management and Energy. Our partnership with the Southern States Energy Board towards rapid commercialization of low carbon technologies. This is a place where we believe that bringing the strength of Department of Energy, the industry partners for the SSEB, along with academic partners such as the UTBG, are places where we can start to advance the world into the commercialization side of low carbon energy space. The other one, and I'm going to just very briefly commend my colleagues both at Rice and at NASA, who have joined us in something called the Subsea Systems Institute, which has come about as a place where we can advance technologies. And our focus has become increasingly on energy systems offshore. We think Texas and Houston have a unique place to grow with offshore clean energy technologies. So with that, thank you so much for the opportunity. I look forward to the conversation and looking forward to hearing from my colleagues. Thanks.
All righty, thank you so much, Ramanan. Let's turn now to Dr. Kenneth B. Medlock III. Ken is the James A. Baker III and Susan G. Baker Fellow in Energy and Resource Economics at Rice University's Baker Institute, and also the Senior Director for the Center for Energy Studies. So Ken, please share your introductory remarks.
Sure. Thanks, Joe. It's good to see everybody. Wish I could actually be participating in something in person. You know, screen fatigue, I think, is getting to all of us, but hopefully there's a light at the end of the tunnel and we'll be able to reconvene together sooner rather than later. Rice has got a lot of things going on. I'm at the Baker Institute. We focus on policy, economics, and markets, how all of those things intersect. A lot of what we're doing is really trying to understand how the energy landscape is evolving so that we can identify hurdles, challenges, and opportunities that exist in the pathway. That, of course, means a lot of interaction with policymakers and other types of stakeholders up and down the energy value chain. That includes interactions with some of my colleagues that are here today with us in the research space, but also with folks in industry. So we've got a really successful engagement on many fronts with that regard. Of course, having a discussion about policy, which ultimately becomes not just a national or federal level discussion, but a local level discussion, you know, requires being deeply engaged with what's happening on the sort of, if you will, stage 0, 1, and 2 research fronts, right? Which is really what we're talking about here when we talk about venture capital, angel investment, those sorts of things, trying to get things to a point where they can be ready for commercialization. The next step beyond that is obviously moving towards industrial uptake and getting into that commercialization phase of new technologies and new ideas. That is where policy plays an incredibly important role. Shifting sentiment in the investor community plays an incredibly important role, and consumer preferences play an incredibly important role. So that's sort of where the rubber meets the road, so to speak. And that's kind of where we position ourselves in a lot of these discussions. Rice more generally has a lot of different things going on aside from where we sit at the Baker Institute. The Welch Institute was recently announced. That's a $100 million gift for advanced materials research. It actually intersects quite nicely with another engagement known as the Carbon Hub, which is really focused on material science, figuring out new ways to use carbon that is captured through, for example, a pyrolysis combustion of a hydrocarbon feedstock, so that you get hydrogen and carbon black. We've also got, and I think you'll hear from Brad Burke later today, the Rice Alliance, which is a fantastic program over in our business school that is really aimed at developing startups and entrepreneurships. And there was recently an announcement about a clean energy incubator that is going to be launched in 2021 at the ION, which Rice is also at the center of. So lots of different things going on, lots of points of interaction. Ramanan mentioned you know, the Subsea Institute, so SSI is another point where we've been engaged with colleagues from all over the place. We're engaged, obviously, with the Bureau of Economic Geology at UT on a number of things, including a big initiative on carbon capture and sequestration, really looking at policy solutions that exist. And again, it's a locally focused type of issue, because that's one thing that a lot of people miss in the landscape of how technologies diffuse into the ecosystem, oftentimes there are very local dimensions on the policy front that need to be tackled to remove hurdles for adoption. And that has got a lot to do with where we sit. Anytime you want to cite infrastructure, that's not a federal level discussion. That's generally a very local level discussion. So thinking about the policy landscape and how it can evolve as we go forward is really where we sit in the broad ecosystem of new technology development and advancement of energy solutions as we move forward.
All righty. Are you done, John? Well, thank you, John. Next up is Dr. Stratos Pistikopoulos, Professor of Chemical Engineering and Director of the Energy Institute at the at Texas A&M University in College Station. So Stratos, welcome. The floor is yours for introductory remarks.
Thank you, Joe. Good morning, everybody. Good morning to the colleagues and all the participants. It's a great privilege to participate in this great gathering. I wish I were there in person. I just want to share with you what is the vision and mission of the Texas A&M Energy to put in the context of our discussions as we go along. First of all, I would like to draw your attention that, pretty much we involve close to 300 faculty affiliates across the Texas A&M Energy landscape, research and development landscape, and across the Texas A&M system. So too many projects and initiatives to mention. So I would like to give you the flavor of how we're structured and what are some key major initiatives. First of all, it's clear that one thing about navigating energy solutions of the future to improve quality of life, we need to take what we call a system-wide thinking. To take a panoramic view of the various technologies that exist for energy, existing, and forthcoming, that are both fossil and non-fossil, including renewables and nuclear. Then the increasing role of materials, catalysts, and separation, the enabling technologies that made the technologies work. To couple this with policy, economics, the law, societal impact, sustainability, all the metrics, safety, resilience, and then the glue that connects all of those things together is what we call multi-scale energy systems. During this very important, as we do scenarios for the future, the ability to quantify and compare apples to apples. And in doing this, we have an energy program, research program. We put a lot of emphasis on education, which is my next slide, and will be something that we passionately believe in, our flagship. So in order to create the mindset and the leaders and thinkers of the energy solutions of the future, we have to take a pragmatic view of how we're going to train these future leaders. And our Master of Science, Energy, and the Certificate of Energy has been designed with this in mind, trying to connect the dots of the various energy emerging aspects, from technology to materials to business to finance to policy to law, and try to create thinkers and students with that frame of mind. And the next slide, just to give you a framework, just a flavor of where we're heading. We're creating these strands which actually focus now on areas like digitization, policy and management, sustainable energy. So we take a versatile group of cohort of students and trying to mingle with them so that they understand the technologies, the policy issues, the aspects of digitization and so forth. And where we see, if we go to our next slide, just to get, so this is at a glance, some of the major initiatives that Texas A&M as a whole on the energy space has been involved. I would like to draw your attention on the big Manufacturing USA initiatives like the Rapid and the Smart Manufacturing. These provide good opportunities about how you build a partnership model. And we go to our next slide. Then what we see, we're going to talk about low carbon, so major strengths towards sustainable energy. Obviously, we say the obvious: decarbonization, electrification, and digitization are playing already a key role. But what we see really a need from academia especially is to understand how we're going to manage the energy transition, because there is no bullet point that we can press a button and we can transition from where we are now at the scenario of the future. So managing the energy transition on an apple and quantifying this analysis on an apple to apple constitutes basic pillar of our systems thinking at Texas A&M. And if we go to our next final slide, just as an example, perhaps some as a prelude of some of our discussions, I have identified big areas towards sustainable low carbon energy, obviously modeling and energy transitions through processification, analyzing resilience and understanding how we create sustainable and resilient energy networks, distributed or decentralized, understanding a little bit more in depth the role of circular economy in an R&D context all the way to commercialization and the opportunities that are created by adopting a circular economy thinking on everything we do. And then the major role, the data science and digitization as they reshape the way energy is going to be traded and delivered, and in general, the interface between the digital twin and the real economy. Thank you, John.
All righty, thank you, Stratos. And I'm happy to announce that our ecosystem extends all the way to Austin. And so we are honored to have Dr. Varun Rai, Director of the Energy Institute and Professor and Associate Dean for Research at the LBJ School of Public Affairs at the University of Texas at Austin. So Varun, please share your opening perspectives.
Great. Well, thank you so much, Joe, and thank you, Brett, for having me here. I participated also in last year's conference, and it was just fabulous. And so just so great to see how this conference takes that discussion forward by bringing much more concrete ideas and discussion forward. And I'm going to take this up in the way you pose this question, Joe, is what are some of our capabilities at UT in terms of low carbon energy, and then also talk about our incubator ecosystem. So, I mean, we are very fortunate at UT, we just amazing how much great work is going on in different institutions. And we at UT are doing very complementary work, providing great force to what's happening in research in Texas. It's the full spectrum of research at UT, all the way from energy storage to CCUS, natural gas and emissions from that, and how to mitigate those, intelligent energy systems, transportation systems, grid optimization. I mean, I can keep going on, but the main thing to keep in mind, and the way we think about it is, it's really our research permeates all our schools and departments. We have over 30 energy centers, and over 300 faculty are engaged in energy research. And that's our basic asset, the human power, the research power that exists. And the Energy Institute at UT really serves as the platform and the glue that connects all these different assets, our centers and our faculty. And that's very central. The other aspect I'll mention is this focus on interdisciplinary research, right? So there's lots of great work that happens in our departments and schools. Much of the problems that we discussed last week in this conference, and what Brett highlighted earlier, are multidimensional. They really require ideas from different corners. And that's really very important, and we pay a lot of attention to that. Last year, we launched an initiative at the Institute, excuse me, Fueling a Sustainable Energy Transition. And as part of that, we funded multiple projects. Over 60 faculty and dozens of students are funded. But a central piece of that was to look at different parts of the same problem from legal, business, science, as well as policy aspects. And so each representative team, by design, it was not one faculty coming and proposing. Rather, these are team-based projects funded over 2 years, substantial funding for each project funded by the Energy Institute. And a typical team involves an engineer, a scientist, a business policy person, a law person, and somebody from communications or liberal arts. That's a typical team. So that's being very important, but also very representative and symbolic of the way we are trying to approach and address these larger, deeper questions. A couple other things we do here, which we believe are very important given the large breadth of work that happens here, is interactions among our own people, right? It's a changing fabric. Every year we continue to hire, lots of great people in energy, and how do we keep that ecosystem connected, as well as something, that we'll discuss more as the day progresses, combining and interacting, creating those forums of internal and external people, right? Even the external world is changing as we speak. Major corporations go through big reorganizations every couple of years. Key people change. How do we keep that refreshed? It's a very big part of what we try to focus on. And the third piece is amplification. A lot of great work happens, but really, as we heard from other colleagues, how do we bring that out for impact in the policy, in the social public, as well as in the business decision-making arena? So, that's very important in terms of what we try to do. Many of our, centers and institutes already got mentioned. So the Bureau of Economic Geology, and in particular, the Gulf Coast Carbon Center in there, the Texas Materials Institute. We have the Center for Next Generation Photovoltaics. It's really, it's amazing. That's, one of the big thrills of my job is I don't have to think about, where is the great research happening, right? Great people. How do you take that? How do you combine that? How do you bring that in terms of amplify and decision making? That's the real challenge and the fun for that matter. I'll quickly pivot and talk a little bit about the incubator ecosystem. The way I think about it is in two ways, the distributed portions and the centralized portion. Most of our schools have their own efforts in terms of innovation and entrepreneurship, great programs on focusing on students, focusing on women entrepreneurship, focusing on social innovation, lots of great things happening at the distributed school level. And then there is the centralized component, right? That is run through the Vice President for Research's office. Energy Institute is a portfolio of the VPR's office. And there are three angles, right? The Office of Industry Engagement that looks at partnerships and legal aspects, as well as in intellectual property sharing. The Office of Technology Commercialization that works with faculty in terms of invention disclosures and licensing and so on. And then we have the Austin Technology Incubator, which is an incubator embedded in the university system that really is, they have had perhaps the longest standing clean tech practice in the country. And this final comment here is the biggest piece here is how do we connect these different existing, how do we make it more efficient? And so we have created, a new portfolio. It's Associate Vice President for Innovation and Economic Impact. And the whole effort is how do we combine these different pieces.
All righty, well, thank you so much, Varun. So it's really impressive to see the strength and breadth of the local university system we have to work with here. So let's get into how do we solve these problems. So first question today is, what do you see as the grand R&D challenges in creating low carbon energy solutions? So who would be first up to take on that question? Ramanan, can I pick on you then?
Sure, happy to do it. No, to me, the biggest challenge today in terms of building a low carbon future is getting battery storage or energy storage addressed rapidly. If that domino falls, a lot of other dominoes very quickly follow. That's certainly one that I think is attracting a lot of interest. A second one, I think that if you give me the opportunity to say second and third, is really looking at how do we take geothermal energy and increase its capability because it is a globally available resource. And the third one is really making affordable carbon capture and utilization. Currently, we've developed a lot of technologies in the area of carbon capture, utilization, and storage, but they are not affordable. And really breaking down that affordability gap, I think, is the issue that we need to address rapidly.
Yeah.
All righty, good choices. Next, Ken.
Sure. So typically when we talk about R&D, we talk about kind of new ideas, and that's usually where our minds tend to go. But one thing that I think presents a challenge, and it gets into the valley of death conversation, just to be perfectly blunt, is there's a massive existing infrastructure for delivering energy reliably and safely. And, you can evolve that over time, but you're talking about trillions of dollars of capital. And one of the biggest challenges I see actually for R&D to result in technologies that integrate successfully into the energy ecosystem is ways to leverage existing infrastructures so that you can more cost effectively adopt things rapidly. If you get into a discussion about utter upheaval, then it can quickly grind to a halt. Because the cost becomes a burden, becomes a massive hurdle that you can't overcome. So in many ways, what that highlights is we should continue to strive for, like Ramanan just mentioned, battery technologies, their continued evolution is vital. That's for a very long time been the holy grail in electric power, right? And it continues to remain so. But we also need to be thinking about ways to leverage existing infrastructure so that we can we can drive an energy ecosystem that is lower carbon at a low cost. To me, that's really, that's where the rubber hits the road, right? When we talk about R&D innovation, it comes down to what's the fixed cost of adoption and development. And that ultimately is something that has to be reconciled before anything moves forward.
Joel, if I can add a couple things just of what Ken said. And to his point of leveraging existing infrastructure. And what I'm going to say is not squarely R&D, but it's pretty grand in terms of the energy transition and the challenge. And that has to do with new infrastructure also. So we have talked a lot about hydrogen, and we are talking a lot about CCUS. These are massive infrastructures at scale we are talking about in fairly short time horizons, 20, 30 years timeline. And that's a grand challenge. It requires all sorts of coordination at all scales. So, transmission, charging infrastructure, hydrogen, CCS. And so I'll add that dimension. We can come back to that. And the second dimension I'll add is, we have not talked about much about people and communities and society. This whole transition is going to disrupt, create opportunities, many for that matter, right? So the net is going to be positive, but there are going to be disruptions. And how do we think about that? How do we think about those interactions, working with the workforce, people, communities, and how do we make this transition just and an equitable and a good one, and not continue to have the same injustices that have been embedded for decades in our energy system. So, I'll add these two new dimensions also.
Yeah.
All right. Well, thank you, Varun. I'm glad you got hydrogen in there. So we see the conversation is around not just the technologies themselves, but also the people and the infrastructure that go with them.
I would like
Stratos, a quick comment?
Yeah, I would like to, sorry, is it me?
Yeah, go ahead.
Add a few comments. I agree obviously with my colleagues, but I'd like to draw the boundaries along the lines that, of the scale of the problem. And we're talking about energy generation infrastructure, its evolution. So I would like to put as number one challenge understanding how we can manage the energy transition, and we should not pick the winners a priori. We let the analysis pick the winners, and as the technology evolves, as efficiencies are becoming greater for batteries, for solar energy, for wind energy, as soon as we understand also the intermittency, renewables cannot be the solution to everything because they increase the need for storage. So we need to understand the evolution of the landscape in terms of infrastructure, new, old, and how we're going to evolve gradually the time frame. And as we go along, which ones are going to be the optimal mix of technologies, sustainable solutions, and the right policies which will empower these solutions for practical use.
All righty. Well, thank you, Stratos. And John, I'd like to pose the next question to you. So what do you see as the role of the university to play in commercialization of clean energy? And does this imply that there should be more funding for applied research in your view? I think you're on mute, John.
So a lot of researchers in the universities do various research because of funding. And if there's a lot of funding opportunities for applied research in low carbon technologies, there will be a lot of innovations in that area.
Okay, any others want to comment on that question then about the university's role to play in this ecosystem and early ideas plus the funding you're receiving?
I'll be happy to jump in there.
Yes. Ramanan, please go ahead.
I think one of the biggest needs for this activity is talent and density of talent, and I think the universities have a unique place to play with nurturing growing talent that is ready to take up these challenges. Again, not thinking within the silo of, say, just a technology or just a policy, but bringing those together. Just like Varun talked about funding opportunities where they bring together faculty. I think the opportunity lies with our students, bringing them to think beyond just their expertise, bringing multiple sets of people so that they can address the challenge, a systems approach to addressing the challenge. And I think that's where our biggest impact can be with talent and providing that density of talent that can start to now transform the world.
Yeah. I would echo this, Joe, because in all our large universities, the structures are there, so we have the technology commercialization, we have all this. It's exactly what Varun and Ramanan highlighted, how we create an interdisciplinary ethos for bringing talented people together, because the solutions of the future are not going to rely on vertical thinking. They require horizontal thinking, where we need to provide the glue of connecting, as I said earlier, technology to entrepreneurship, to understanding also policy, both national and international, and how this affects technological solutions. And the winner is not going to take it all, right? So because somebody has created the best membrane on planet Earth, doesn't mean this will be a commercial success. So we need to put it in a bigger scale and understand this connectivity among technologies across disciplines.
So let me add something to this, because it's not always about a bunch of money being funneled into a university. Sometimes universities can actually take some relatively low-cost steps towards really training our next level of innovators, if you will, to a broader understanding of interdisciplinary approach. And we've been doing this for a few years at Rice. We actually fund postdoctoral fellows and graduate students across campus in different divisions here at the Baker Institute. And it's always interesting because it's sort of like you create this double coincidence of once we're looking for the deeper bench so we can actually contribute the hard science to the policy and economics discourse. But there are students who want to understand how policy works. They want to understand how markets work. And one of the things we've been really successful in doing is bringing people, for example, from chemical engineering in to have a real discussion about market-oriented solutions and policies that can support those types of solutions. And it's always a massive learning curve. I mean, these are really smart individuals, but when you start thinking about markets and policy, it is a different discussion than thinking about the technologies. And when you can get the two to meet, magic can happen. So universities really need to take a proactive stance in accelerating those types of things as well.
All right, well, that was the answer to our next question there, Ken, but in terms of things that we should be doing differently about training students, so is there anything else, Varun or John, that you would consider in that space that we haven't covered yet?
Well, one thing I'll add is, it's not only what is our role, or do we see a role, rather it has become the central imperative, right? What I see in our colleagues and students is this deep desire to connect to the actual action and actual difference in the transition. And this is totally different than how even researchers used to think in the energy space 20, 30 years ago, right? It has to connect, and there's a deep hunger for that. So that's very exciting. At the same time, when I interact with our funders, both government agencies, but in particular our corporate funders, they care a lot about their investments and how their research investments are going to enable them to really make a difference and make new headway in their business. So, I'm seeing this very interesting coming together of great excitement on campus for, going further, starting from the lab, but going further as well as on the other side, a real drive and expectation that, hey, we are not going to stop in the lab. What are you all doing? So I think, the big drivers are coming together, and it's a very exciting time. I totally agree with Ken, though. It doesn't necessarily always involve, big resources, funding scales are big, and timeline is very short. So funding at all scales will be very, very important. So I'm not going to discard that yet. It doesn't have to start there. There are many things, there are many pieces. These are big institutions. We have been around for decades. Lots of great pieces to work with, and there are many, many low-hanging fruits that can get us quite a long way.
John, any final thoughts on that? What should we be doing differently on training?
Oh.
Okay.
Yeah.
Stratos, go ahead.
Yes, I think for me, the role of universities, the panel like this, the role of training, education is central, because that's how we can reshape the future. Because it's one thing to talk about funding interdisciplinary projects and so forth, and this is happening up to a point. What needs to change is the mentality that we look at problems in a holistic approach, and we create programs, training programs like our Master of Science program, which takes a holistic approach to all the aspects, takes a breadth approach as opposed to in-depth approach. So it takes, like Kenneth mentioned, like chemical engineers of all sorts, mix them with policy people, with business people, and creates a unique educational environment where then by design, everybody is trained towards thinking about the roadmap and energy evolutions on R&D, and that will eventually result in creating the ecosystem of thinking towards sustainability and commercialization effort.
Yeah, Joe.
Go ahead, John.
I want to comment on a lot of the universities have got certificate programs and master's program in specialized areas. But if we want Houston to be a low carbon capital of the world, I think there should be a concerted effort among all of us to have graduate programs, certificate programs in low carbon engineering or low carbon systems.
Okay. Well, thank you, John.
One more thing. I think one often less traveled road is experiential learning. And I think students really miss that part of it, where they do and fail. Learning to fail, I think, is a crucial learning that we ought to give our students more opportunities at. And I think that's, if there are pathways that we can integrate experiential learning into our traditional learning methods with this approach of systems approach and learning to fail, I think that would be a huge benefit to our students.
And I couldn't agree more with Ramanan there, Joe. I'll tell you a little quick story about myself. When I was a graduate student, towards the end of my studies, I took it was engineering, but I took a course in global energy policy, and at the end of the course, we did a 2-week international tour and really got to see the people, the infrastructure, the CEOs, the politicians, and it changed my trajectory. I completely, it changed the course for me. But that's the big thing with energy. It's real, it's hard, it's infrastructure, it's physical, it's people, and building that experience in is just going to be so much more important, especially as we think about the transition. So I think that's a great important point. One of the big losses because of the ongoing pandemic is the difficulty we're having in continuing to provide that type of experience. So it's a lost opportunity, but hopefully, as Ken started in his initial comments, we are able to get back quickly to doing this.
Yeah, I just add one thing. I mean, everybody is sort of hinting at building a successful team. And there's really no better place to begin that than in the educational environment. I mean, if you're building a football team, you don't want 11 quarterbacks on offense. You'll lose every game, right? It's important that you have specialization in skill sets that can come together and actually work in harmony. And in many ways, when we talk about experiential learning, I think some of the most successful programs that you see around the world do exactly that. They actually bring interdisciplinary approaches to that sort of team building aspect of trying to understand how you move something forward. And I'd like to see a lot more of that, quite frankly, because I think that's actually where you can really get to move the needle.
All righty, great discussion. So a lot of research on innovation ecosystems says that coordination is key to jumpstarting. So how does each of your institutions coordinate with each other, with governments, venture capitalists, and accelerators, et cetera, and make the coordination work? Who'd like to start?
I can say a few things about what we are doing and what we are not doing. I think I will say that, in the mentality in the US R&D system has been changing and shifting towards collaborative environments, and I think that's good. The Manufacturing USA initiatives and the institutes that have been, we're close now to 16, 17, are helping towards creating a Pan-American thinking about R&D, which was lacking before because, the way the funding agencies and so forth have been working on. So creating perhaps not yet a full interdisciplinary R&D program, so from a funding point of view. So we need to understand this. Now, the thing that is missing, and I've been in Texas for 6 years, so I apologize for colleagues who've been here throughout their lives, I don't see a Pan-Texan kind of, get-together type of forces. There is this wrong hypothesis that, of course, competition is good and we need to keep on doing this, but perhaps by getting together and agree and, creating synergies for a Pan-Texan kind of approach, at least to the energy evolution of Texas towards a sustainable energy solution through concepts of circular economy and all this, which is business-driven, science-driven, technology-driven from our own institutions, will be a very helpful start. And I hope this panel and the initiatives that Brett has been pushing will create us towards this type of framework.
Okay, so we've got a great start at it today. Would anyone else like to take on that subject, or shall we go to the?
Go
ahead. I just add something on the. Oh, go ahead, John. Go ahead.
I'd like to underline what Stratos said. We are Prairie University. We are part of the Texas A&M Energy Institute. So we're able to collaborate with some of their researchers and do some work there. But in terms of collaborating with other institutions, UT, RISE, or U of H, we don't. So hopefully this venue allows us to have a better, stronger collaboration among the institutions in the state. Thank you.
So one thing I'll add is we've identified a lot of the things that have been discussed actually over the first day of this conference last week, as well as what's been brought up already this morning. In many ways, integrating new technologies and finding solutions to some of the world's most daunting problems is the ultimate coordination problem. You're talking about connecting points along massive value chains, and it requires coordination amongst all the actors on those value chains. One of the things that we've been successful in doing is convening working groups that really do reach sort of deep into different elements of those value chains to discuss what those potential obstacles to coordination actually are. And sometimes they're pretty large. Other times it really is just more about opening a conversation, but you can't understand that until you actually open the conversation. In cases where those obstacles are large, you can actually come up with innovations on the market front, innovations on the policy front, so that you can actually begin to reap the rewards of the innovations that are occurring at some of the more well-known research institutions on the science and technology front. So all of these things come together, and that really is why coordination. You really only overcome those obstacles if you get together. That's critical.
All righty, so yes, this is about Houston. And do you think that Houston has a brand or image challenge in pursuing low carbon opportunities? And how do you factor in Houston's development needs in the work and collaborations of your institutions?
Being a native Houstonian today, I'll take that on. But and Houston certainly has an image issue, right? With take the case of Amazon when they were looking for where they wanted to put their the second headquarters. Houston did not even come into the top 20 in their discussion. So Houston has an image issue when it comes to cool new technology issues. And a lot of the low carbon challenges have been contextualized in the notion of new technologies. I think reframing this along the lines that Ken has spoken, Varun has spoken, all of us have spoken, focus on the emissions, not on the fuel, not on the source of the energy. Focus on the problem, and the problem is carbon. And if we can understand, if we can agree on that, and then say that it's not just a technology play, but it's a systems play, then I think Houston has a huge advantage because we know how to do systems, and we've done this repeatedly. And I think it's how do we reposition this conversation rather than for it to be considered a technology play or a cool play.
All righty, other comments?
I'll just say it cuts both ways, right? And when we talk about the new technologies and investments, they might have a certain direction or a certain tendency, and those might be reflective also of how new pieces of ecosystems are getting built and some other priorities. When I think to down the next 3 to 5 decades, the capabilities, the human power, the technology power, the systems level approaches that Ramanan just talked about, those are just so critical. And Houston being such an integral, deep, central in many ways part of the Texas energy ecosystem, and Texas for that matter, such a central part of both consumption and production and the industrial powerhouse of the U.S. economy. I don't think that's a longer term issue. Folks who understand how we can, what are the pathways to actually do this, make this possible, they have to take Houston very, very, very seriously. I'll, as a non-Houstonian, I'll just say that.
All righty, well, great comments.
I would like to echo this, Joe, just a few remarks on these thoughts. So when people refer to Houston, usually they refer as the capital, of the business capital of Texas. So, by Houston, they mean the entire, Texas. And I think for all the points that the colleagues mentioned are important. I think, one of the issues that as we understand how to manage the energy transitions of the future through this systems type of approach, resilience is key. So, one of the aspects that perhaps the city of Houston, and that area is suffering is from resilience type of thing. So we need to understand how, we can manage resilience in a way as in tandem with managing our electrons and carbon atoms. So, so in an ecosystem. So, and then water, we should not forget the food, energy, water nexus, that's central for Texas as a whole. We'll talk about energy, but we suffer from water. So, and the two are very connected. And so we need to understand the ecosystem and the transitions towards a sustainable ecosystem as a whole.
Agree fully. And when it comes to getting these things started, so what sorts of specialized funding vehicles are effective in commercializing ideas from students and faculty? So what funds do you have at your disposal, and what works there?
I'm sure other colleagues will have great things to share. Something I'll just mention, there are many different things, but the initiative I referred to earlier, the Fueling a Sustainable Energy Transition, or the FSET initiative we started last year, which was a very specialized funding vehicle that by requirement, it had to be interdisciplinary teams of at least 4 or more faculty from different parts of the campus. And that was all in, internal resources, which gave us a lot of flexibility and runway. And it attracted a lot of interest, almost triple the interest that we expected. Over 125 faculty and other researchers participated in the call. And it is symptomatic of two things, how much excitement there is, but then also when you really create vehicles that excite and provide that opportunity, visionaries and leaders have that in them to come together and realize that addressing the next level of problem that really enhances the impact of their work requires that type of connected approaches. So I mean, that's something we have had great success with. And also we're starting to see already, we are 9 months into the process, another year, little over a year to go. We're already seeing very, very promising headways, not certainly all of basic science research and publications are an expectation, but each of the projects are also, we are working closely with them. Some of them have startups, large proposals, other things that are happening on an ongoing basis. So that's been very promising for us.
All righty, another quick example there.
Most of our projects in low carbon comes from either National Science Foundation or Department of Energy. And their priorities might be very different from that of the city of Houston or if any surrounding counties. So it might be useful if, for instance, they are specialized funding from the state or even from the city to put us on the foot of getting low carbon energy projects.
Okay, good comments, John. And I'd like to save a brief minute for some of the audience questions, but to close this panel, formal questions, in a couple of words, what will it take to achieve net zero by 2050? So give us your best sounding statement here. So who would like to start? Stratos?
Yes, always. Listen, I think understanding, first of all, the electrons and carbon atoms monetization, and this is critical in managing energy transitions, as I mentioned. So what will take is understanding the scale of the problem as well, because very often we hear some, like monolithic solutions.
Okay, so carbon and scale, and I'm going to keep it short for everyone. Let's go, Varun.
We should not forget the chemicals, right? So, it's not all
carbon, scale, and chemicals. All righty. Varun.
Very quickly, total commitment and a new social contract.
All righty, let's go, Ramanan.
Focus on the emissions. Don't focus on solutions.
There we are. And Ken?
Innovation across multiple disciplines.
All righty. John, you've got the final word here.
I think the will of the people to do this.
Will of the people. Okay. So great comments.
Okay. So Joe, thanks for a great panel. That was really amazing. We do have a couple minutes for questions, and I'll just tee one up for the group. And it kind of builds on something I heard John say. This is a question from Brian Weeks. It says, a challenge for Texas to claim leadership in energy innovation is the lack of structured state investment in clean energy tech R&D. Aside from funding for universities, there seems to be little state funding for clean energy tech R&D, as you see from the California Energy Commission. Thoughts? What should we be doing on the state level to stimulate more of this investment in this space?
Well, I have lots of thoughts on this, Brett. I don't know if we have enough time to get into everything, but some of this really does start with, at the state government level, incentive structures that can be put in place. So things in California that also exist are like the low carbon fuel standard, which actually is helping propel a lot of things on the hydrogen front. There's some discussion about what would it take for something like that to happen in the state of Texas. Those are more around implementation. The California Energy Commission does a lot of stuff. There really is no similar organization in the state of Texas. As a matter of fact, when you look at the state of California, its government infrastructure is very much set up like a mini nation in many ways. And so that actually does afford a capability to do different types of things through the mandates through those different agencies that you don't necessarily have in other states. So it really, if you want to get to that about Texas, you got to talk about organizational structure within the government. And that's a much longer and much more arduous conversation, just to be blunt. There are some things that can be accelerated through like the School Land Board, through the General Land Office. I mean, there's lots of things that are being explored right now related to carbon sequestration, but in terms of broad R&D funding, that's a totally different discussion that you could probably spend an hour talking about.
But I think our panel, panels like this, I mean, we think always of top-down approaches, but bottom-up approaches are important. So, like if we unite our forces and synergize, we can play a role in pushing the agenda towards this direction. And I think this is somewhat lacking. So there is no synergy among the universities to begin with, let alone the society to go towards that direction. And I think we can amplify this and synergize these efforts as we try to, close the loop from bottom up to top down.
And Brett, just to piggyback on that, I think Texas is unique. Our government structure is unique. As well as anybody else, CREZ happened because of government intervention. And that has fundamentally changed how Texas has developed as a wind energy and solar energy provider. We need something like CREZ to happen for low carbon future, and nothing like a problem to focus our government officials. And I think this current pandemic, the current economic downturn, the pushback on oil and gas is all going to lead to, I think, a significant funding opportunity that the state can and will invest in trying to advance workforce as well as economic development.
One major complication in all this, and I know everybody knows this, has to do with state budget. And right now, when you start talking about allocating state funding towards basic R&D, there's a limited capacity to do that. And it really does become an issue of how do you actually scramble for those resources and allocate them in the most efficient way. The state universities, you guys deal with this all the time. At Rice, we're a private institution, so it's really not in our purview. Most of our engagement on R&D is actually through industry and foundation and federal government entities. So it's a different kind of discussion. But at the end of the day, collaboration across institutions is critical. I think we've hit that nail on the head many, many times in this panel. And thinking about how that can actually convey a benefit to the state of Texas is, I think, something we're all doing. But it doesn't necessarily mean that funding will come specifically from the state.
I just leave my role as moderator here and just sort of comment on that, on the CREZ thing. CREZ didn't really cost $1 of taxpayer money, it cost ratepayer money. And it really was started by the industry. So these things don't magically happen. They happen because people work hard on them for many years. And in CREZ, what really happened, the untold story, and someone will write a book on this one day, is you really had the West Texas economic development people, teeing up, getting together with the renewable developers and the utilities and saying this made sense for all of us. And so, trying to put that big tent together is really what we need to be thinking about. And this is kind of one of the things I think this discussion, has at least highlighted for me, is that we have these enormous resources here in the state. We just have to figure out, and I think Stratos mentioned this, we really do have to figure out how to use them together.
And if I can just say a word, Brett, these are exactly the times where entities and communities and states that can plan, pivot, invest, dig deeper, these are hard times, but also, raise a possibility to reposition and pivot. Those are the entities, organizations, states, communities that will really position themselves to be much more successful and resilient.
I think that's exactly right. And Varun, I don't want to lose the comment that you made at the very beginning that this is going to be very disruptive. We didn't really talk about that very much, and maybe others want to comment as we sort of transition out of this panel. But we do need to think of how this is going to affect and have have an equity and justice lens on this as well. I think it's a really important comment.
And that's where managing the energy transitions is key. Right.
Okay, well, great discussion, Joe. Thank you so much for really kicking this off with a really interesting discussion. Guys, we ought to get together more often.
Agreed.
I think we can really accomplish some great things. And I know, Joe, you're in the middle of all this at Shell. You work with all these folks, but I think this is the kind of thing that if we can do it more often and really have these dialogues where we put all the great minds together, we'll really accomplish some amazing things.
Some great questions, Brett. So we're talking in the chat box about circularity, batteries recycled, nature-based solutions, and then where's the walk-up lab space availability in the Houston area. So really good questions in the Q&A session that we can also take on board as part of this opportunity.
Yeah, and we'll get to those. I thanks for bringing that up. We didn't have time to get to a lot of them, but please, those who are listening in, please put your questions in the Q&A. We'll get to them during the day as we can, and we'll definitely come back and answer them afterwards. I know there were a number of questions about specific technologies, about geothermal. Ramanan mentioned that about CCUS and others, and so we'll pick those up hopefully after the conference, if not during the day. So please continue to put your questions in the Q&A. And Joe, thank you so much for doing this. Thank you for the panel. I think we're going to take a 15-minute break and come back with a really great panel on accelerators and incubators, and probably, as I mentioned before, kind of an interesting announcement. So you'll want to be here for that announcement. So stay tuned. Let's take a 15-minute break, and we'll be back right at 11. We're doing really well on time. So thank you, guys, and we'll see you soon.